about Tucson Fire Department, readiness and incident predictability. Thank you, Brian.
Thank you, Chris. Good evening. As Chris said, I'm Brian St. Denis, and I will be talking about my project. It's Tucson Fire Department, incident readiness and incident predictability. I will begin by introducing the project and study area, and then explain how I went about the project, the results I obtained, and then conclude the presentation with how this project can be refined in the future. So let's get started with the introduction. Tucson Fire Department was looking for some commercial software to monitor the coverage of the city and within a 5-minute response time, and give them some situational awareness and information for better decision making. They requested the map be refreshed within 2 minutes, and they had also talked about an optional proof of concept predictability model that they could use to look at in order to try and stage vehicles to maximize their coverage and reduce the response time. Tucson, Arizona is located in the southern part of Pima County, approximately 60 miles south of the Mexico-United States border. It was incorporated in 1887, with its first fire department organized in 1881 and commissioned in 1883. This fire department, first known as Tucson Hook and Ladder Company, and later renamed to Tucson Volunteer Fire Company, was an all-volunteer force with 2 hose carts. They were responsible for 7,007 people within 1.8 square miles, as indicated by the pink-purple square. Today, there are 22 stations and 63 vehicles responsible for over 535,000 people, covering 226.7 square miles, indicated by the blue part. So here are some of the methods that I've performed in this project. I created a multi-layer map to help Tucson Fire Department improve their service to their community in various ways. The primary layer was a coverage analysis layer. This layer was created using Model Builder and ArcGIS Pro, and will show where there are places in the city that are covered within a 5-minute response time limit, or conversely, areas that are where there's gaps in coverage. This is a 7-step model built in order to create the coverage analysis layer. Step 1, select by attribute. The coverage analysis needs to be built off of vehicles that are available to take the calls. The computer-aided dispatch system labels these vehicles based off of certain criteria. Select the vehicles marked as available and create a new layer on the map with them. Step 2, input facilities. Use a new selected vehicle layer as the input for the facilities in the Make Service Area Analysis Layer tool. That's a mouthful. These are the points that the coverage area will be calculated from. Step 3, Make Service Area Analysis Layer tool. Esri describes this tool as it, quote, makes a service area analysis layer and sets its analysis properties. A service area analysis layer is used in determining the area of accessibility given a cutoff cost from a facility location, unquote. Configure the tool with variables such as, but not limited to, direction of travel, which is to or from the facility, time of day to calculate the coverage off of, either current time or a specific date and time if you want to look at rush hour traffic. Polygon type, such as having coverage areas overlap or dissolve into each other, or actually split and have borders between them. Step 4, solve. Basically, solve or calculate the service area. This calculates the polygons of the service area that shows the 5-minute response time of each vehicle. Step 5, clip. Clip the service area polygon to the Tucson city boundary. This will remove any excess coverage outside of the city boundaries. And this helps clean up the map. Step 6, clear. Basically, you're just going to clear the previous selection or the units that were selected in step 1. This needs to be done to clean up the map and make sure there are no available and there are no vehicles selected before the model runs again in order to perform the calculations off of the correct vehicles. Step 7, remove. Clean up unused layers by removing the service area and the selected units layer that were just created. This will clean up the map of unnecessary layers and create clean data for when the model runs again. The next layer is the move-up analysis layer. Move-up analysis is performed when all of the fire station's resources are busy or unavailable. Depending on how much longer the units are anticipated on being unavailable, other stations' resources may be called upon to stage closer to the empty station's emergency service zone in order to cover down on calls in the overtasked area if they are needed. This map shows 22 different emergency service zones or primary areas of responsibility for each fire station. Adding the fire station and vehicle locations will allow you to perform the move-up analysis. Next is the heat map analysis layer. The heat map symbology helps visualize point density. This is especially useful when you have a lot of points, and in this case, Tucson Fire Department gave me over 500,000 points, ranging from January 1st, 2014 to March 3rd, 2019. You can see how changing the symbology makes it easier to visualize where most instances of the calls come from. The proof of concept predictability models to be tested were going to be based off of the k-nearest neighbor and random forest regression algorithms, as well as attempting to create an artificial neural network. The data that I had gathered involved call data from the fire department, hourly weather data from the National Oceanic and Atmospheric Administration, or the NOAA, air quality data from the Environmental Protection Agency, or EPA, building materials from Pima County Assessor's Office, and demographic data from the Census Bureau. Unfortunately, creating these models is a very complex and time-consuming task, so this nice-to-have request by the fire department was not completed by the time of this presentation. So, on to the results. The requested refresh time for coverage analysis was within 2 minutes. The model ran, calculating coverage based off of 63 vehicles, refreshed within 38 seconds, well within the 2-minute request put in by the fire department. The coverage analysis layer showed that there are gaps in coverage throughout the day. The areas that seem to have less coverage than other areas are in the western and southern parts in the city where population is sparser. For the move-up analysis, let's focus on Station 17 in the east side of the city. Station 17 has 1 unit assigned to it. Let's say it's on a call. What stations will move units to help cover Station 17's area? Station 9 could stage a unit further south, better cover their own area, and be available to help assist Station 17 in case another call comes in. Because Station 19 is so close to Station 17's emergency service zone, they can either stay at the fire station or maybe move further east in order to help with coverage, depending on what they have going on. The heat map analysis shows that call density was clustered in pretty much the same areas year to year. You can see that these look pretty similar to the first one that was shown with all the data. This is the heat density map of all the call data Tucson Fire Department gave me. You can see the primary hotspots for calls. The brightest yellow area has the highest density of calls. This is the Greyhound bus station area in downtown, out near Station 1. North of that is North Oracle Road, between Station 1 and Station 8. Moving east is a spot between Station 5 and Station 7. This is the intersection of Alvernon and Grant. The point just east of Station 7 is the Tucson Medical Center. And over by Station 16, we've got Broadway over by Jesse Owens Park. Now, Broadway and Speedway tend to have a lot of calls at their major intersections, but this one seems to have the most hits in the area. And then lastly, we've got the area between Station 14 and Station 10, and this is the Tucson Rodeo Grounds. Okay. To conclude, I was able to help Tucson Fire Department solve their need to visualize gaps in coverage or how well they can cover the city within a 5-minute response time, and doing so well within their requested refresh time. This was done with a multi-layer map showing vehicles and fire station locations used in conjunction with coverage analysis layer, a move-up analysis layer, and a heat map layer. Some items that may need to be addressed is that the Tucson Fire Department requested the coverage be calculated off of vehicles and not fire stations, because the vehicles will occasionally be staged away from the fire station. This causes issues because if the vehicle's in motion when the coverage calculation begins, it may not be there when the map is refreshed, which can cause a false positive or showing that an area is covered when it may in fact not be. Because Tucson keeps expanding, there's always gaps in coverage with a 5-minute response time. And also due in part with the current layout of the fire stations. Those gaps can be minimized with the better situational awareness and staging of the vehicles. It was difficult to do more because access to the city's computer-aided dispatch system and geo-event servers were limited for privacy reasons, of course. They were kind of worried about HIPAA violations. So that left me with limited access to finalize the project. This project can definitely be refined by the talented GIS folks at the City of Tucson with access to all of the resources that they have. Call data from the fire department should be standardized and easier to classify, at least for someone outside the organization that may be looking at the data. The call codes and descriptions have changed within the last 18 months and at least one other time in the 4 years of data I was given. Some descriptions are ambiguous, making it difficult to accurately classify the call as fire, medical, or other. These issues make it difficult to clean the data and perform an accurate analysis. So what's next? This project can be refined once the City of Tucson completes their own local network data set. That is creating a layer that has speed limits and stop signs and everything else that you normally get when you use Google Maps or something like that. And Tucson Fire Department standardizes all their call codes and descriptions. Once that is done, they can have someone with access to their computer-aided dispatch system and geo event server create a web application with these maps, including an appropriate dashboard showing all the relevant information from the computer-aided dispatch system. Like if a fire station is dried out of units, all the units are out on calls, then they can have something pop up on the dashboard or how many calls they have during the day. This can also lead to an automated move-up analysis map. Lastly, once the predictability models are complete, they can be improved with more data such as elevation models, more demographic data, solar and lunar luminescence, artificial light data, and other potential variables. Thank you all for coming out and listening to me. I hope you enjoy the next 3 presentations. Anybody have any questions?